Hi everyone, this is our last lecture in Unit 8. Today we're doing Lesson 8.8, Rates of Change in Exponential and Logarithmic Functions. Logarithmic and exponential functions are both involved in problems of rates of change. Let's take a look at Example 1 from Learning Resources. Calculate the average change in students per computer during the entire period and during the middle 5 years of the data. The middle 5 years would be from year 5 to year 9. Just by looking at the table of values, we can conclude that as the number of years go up, students per computer goes down. Step 1 of calculating the average rate of change. Let's first calculate it for the entire time period using the value of numbers per student per computer for year 13 and year 1. For year 13, there were 10 students per computer, and for year 1, there were 125 students per computer. Therefore, the average rate of change will be 10 minus 125. And on the bottom, it will be time elapsed in years. That would be 13 minus 1. And if we work that out, that would be negative 9.58. So we can conclude the average rate of change in students per computer decreased about 10 students per computer. In step 2, we have to find the middle 5 years, which is from year 5 to year 9. For year 9, there were 18 students per computer, and for year 5, there were 32. So the average rate of change is 18 minus 32 over 9 minus 5. That would be negative 3.5. So the average rate of change in students per computer decreased about 3.5 students per computer. Now let's take a look at example 2. The sketch graph of y equals to 10 to the power of x is shown on this slide, and y equals to log x is shown on the next slide. Discuss how the instantaneous rate of change in the values of y for each function changes as x goes to infinity. So you can see from this graph that the instantaneous rate of change in the y value is close to 0 for very small values of x, and that's this. But as x increases, the instantaneous rate of change gets larger very quickly in an exponential function. So as x goes to infinity, the instantaneous rate of change goes to infinity too. As you can tell from the tangent line, when we take the tangent line from a lower value of x, a much gentle line, and when it is a higher value of x. Here's the graph of y equals to x log x. So as you can see, the instantaneous rate of change in the y value is very large for small values of x, but as x goes larger, the instantaneous rate of change gets smaller very quickly. So we say that as x goes to infinity, the instantaneous rate of change goes to 0. And we can see this from the tangent line. When we take a look at the tangent line at a smaller value of x, the line is much steeper than if you take a value at a comparisonly a larger value of x. Okay, so that's the end of this lecture. Thank you guys for watching. Remember to do your activity as well as your assignment and upload them to teachers to mark. And I'll